Hi, welcome back to the massive open online course of MAT 522. In this third video, we will learn how to model the second applications of the second order linear differential equation, LRC circuit. Now, besides the spring mass system, an LRC circuit, the series type, also possesses the similar model. If the function I denotes the current in the LRC series circuit, as shown in the figure here, then the voltage drops across the inductor denoted by capital L, resistor denoted by capital R, and capacitor denoted by capital C obey the Kirchhoff's second law. That is, the sum of these voltages equals to the voltage impressed on the circuit. Mathematically, L multiplied by di over dt plus R multiplied by I plus 1 over C multiplied by Q equals to E, when Q denotes the charges and is related by I equals to dQ over dt. This mathematical model can be further generalized into L multiplied d squared Q over dt squared plus R multiplied dQ over dt plus 1 over C multiplied by Q equals to E. Again, I here denotes dQ over dt. Or even in the more simpler structure, simply LQ double prime plus RQ prime plus 1 over C Q equals to E. Similar to the spring mass system, an LRC circuit also exhibits three different types of electrical vibrations. First, free undamped vibration, in which in the model, the resistor R does not exist. Second, free damped vibration, in which now you observe the existence of the resistor R in the model. Finally, the existence of the external vibration at which additional voltage is applied to the circuit, denoted by the non-homogeneous term E in the model. Now, let's look at this example one to see how we can model an LRC circuit. An LRC circuit has resistance 20 ohms, an inductance 2.5 henries, and capacitance 0.02 farad with an applied voltage of E 300 volts. Assuming that initially there is no current, but there is initial charge of 2 coulombs. Construct a second order linear differential equation to represent the scenario described above. Now, constructing an LRC model is rather simpler since all the required information is obvious from the questions. If we collect all the 4 different numbers that exist in the questions, we can next substitute all this value into the models, giving us 2.5 Q double prime plus 20 Q prime plus 1 over 0.02 Q equals to 300. And this model we can further simplify into Q double prime plus 20 divided by 2.5 Q prime plus 1 over 0.02 multiplied 2.5 Q equals to 300 over 2.5. In other words, the computations and the simplifications of this model gives us Q double prime plus 8 Q prime plus 20 Q equals to 120. In addition, this model is subject to 2 initial conditions. The initial charge Q of 0 equals to 2 and no initial current Q prime of 0 equals to 0. So this is the model for this example number 1. That's it for this third video. See you in the next for the solution to the LRC circuit.